Welcome back for part 2 of Module 5, Lesson 1, Roots. We're picking up here where we left off, starting with example 3, where we're going to find negative square roots. And you can see the only real big difference between the negative square roots and the other square roots we've been doing is it has a negative sign out front of it. That means that the answer is going to be negative. Yes, I know you're thinking, wait a minute, there wasn't a fraction in the last one, but that's just an extra bonus for this. The fractions are super easy to do. All you'd have to do for this one, of course, we're going to need to take and bring up our answer key. Because the negative sign's outside of it, we're going to put the negative sign out front again. We need a fraction for an answer, and then we're going to take the square root of each one of the pieces. The square root of 25, that's 5, because 5 times 5 is 25. The square root of 36, that's 6, because 6 times 6 is 36. Hit accept, hit check, and it really is that simple to do these. Yeah, I mean, I could make it wordier, but why? All right, your turn. Pause the video. Do this one. I'll wait. Okay, I waited. You really should be done by now. Negative sign's out front. That means your negative sign goes out front. 49 is a perfect square. It's the square root of the square of 7. So the square root of 49 is 7. Check your answer. Man, this stuff's so easy. Now, we've already talked about the idea of example 4 back when we were doing order of operations in module 3. And I gave an example there of the square root of negative 25, and I told you that that was an irrational number. Now we got to simplify the square root of negative 16 using rational numbers, and if the expression cannot be simplified, explain why. And this is going to be the same type of situation where there's no number you can multiply by itself to get to equal negative 16. Well, my wife was kind enough to point out that the neon green running shirt I used for cross trainers after school today probably wasn't a good thing to use with the green screen behind us, so I switched back into what I had on earlier. Going on with the lesson, there is no rational number square root of negative 16 because no number times itself is going to equal to negative 16. 4 times 4 is positive 16. Negative 4 times negative 4 is positive 16. And I know somebody out there is thinking, can't I multiply negative 4 times a positive 4 and get negative 16? Yes, you can. But if you do that, you're multiplying two different numbers. Negative 4 and positive 4, they're not the same thing. Now, what would be the difference in these two problems then? You've got the square root of negative 16, and you have the negative square root of 16. The one on the left is an imaginary number. The one on the right is negative 4. Because the negative sign is outside the radical, you can work that one. All right, your turn. Pause the video, work the problem. And my turn. Simplify the square root of negative 100 using rational numbers. If the expression cannot be simplified, explain why. The expression cannot be simplified. There is no rational number square root because no number times itself equals negative 100. Check it. Easy math. Alright, enough of this kindergarten stuff. Let's step up our game a little bit. You can solve operations by using inverse operations. And remember, inverse operations are operations that undo each other. Vocab word. Squaring or taking a square root are inverse operations. So we're going to select each card to see an example. The square of a number is going to be, for example, 9 squared. That's going to be 81. However, to take the square root of it, the square root of 81, that's going to be 9. These are inverse operations because they do the opposite thing to the number. One multiplies it times itself, the other goes back to the root to find out what was multiplied by itself. To solve an equation in the form x squared equals p for x, you have to undo the operations by squaring x by taking the square root of both sides. And you can see that right here, and it's a little, just focus on one line at a time. The original equation, x squared is equal to p. But they don't care about x squared, they want to know what x is. So to find out what x is, they're going to take the square root of x squared. And if you do it on the left, you have to do it on the right. Now the square root of x squared, they're looking for the positive and negative square root of it. The square root of x squared, well, that's just going to be x. And notice that the positive or negative just disappeared on the left because we don't know, it's just x. However, the positive or negative on the right stayed, because now we're going to say that x is either equal to the positive square root of p or x is equal to the negative square root of p. It says there will be two solutions, a positive square root and a negative square root. So let's apply this to some actual numbers, and I think you're going to find it makes more sense. They want us to solve t squared is equal to 169. But we don't really care what t squared is. We want to know what t is. And to find out what t is, all we have to do is take the square root of both sides, and whenever it gets done loading here, that's exactly what we're going to do. So you start off with writing your original problem. You always write the original problem first. From there, we're going to take and put a radical over both sides, the square root of t squared and the square root of 169. Now they're not going for a principal square root here. They apparently want you to indicate that you know it can be both a positive square root and a negative square root. So they've done positive and negative on both sides, but you're going to find that the one on the left, it's just going to disappear like you see right there, because the square root of t squared, well, the t is the number we're looking for. We don't really know what it is, but on this side, the positive and negative stays put, because this is what actually applies to the number. And of course, the square root of 169, that's 13, because 13 times 13 is 169, and it could be a positive 13, or it could be a negative 13. Either one of those is a legitimate answer. So t is equal to 13, or t is equal to negative 13. And if you really wanted to go on here, you could click on that and go for that happy sound, and there it is. But it didn't make my happy sound. I'm so sad. Okay, I'll get over it now. To talk about it wants to know, why do we take the square root of each side? Well, remember, you have to keep your equation balanced. If you do something on one side, you're going to have to do it on the other side. Once again, it's going to be your turn to solve a problem, and this one's going to be interesting. No, you may not use your calculator. Use your brain. You've got a very capable brain, and this is not a hard problem. Do it. Now I'm going to show you how I would show the work on it. I would start off by writing the original problem, which is going to be, come on, there we go, m squared is equal to 0.09. And then there's no reason to rewrite another line. I'm just going to take and put my radical on both sides. It's going to look just like that. And of course, they want us to do the plus and the negative. Although there's really no reason to do that on the left, they want us to do it anyhow, so we're going to do it. Now the square root of m squared, that's just going to equal to m. And then we're going to have a positive or negative, and we have to figure out what number times itself is going to equal to 0.09. Well, first question is, do we know the square root of 9? Of course we do. Square root of 9 is going to be 3. How many decimal places are we going to have to bounce when we multiply that 3? 1, 2. So that means my decimal has to be right in front of that 3, so that when I multiply the two 0.3s, there's two bounces of my decimal, just like this. 0.3 times 0.3 equals 9. 1, 2, 1, 2. Annex in your 0, and that takes you right back to where you were right here. So our answer is going to be plus or minus, come on baby, let's give me the device, there you go, plus or minus 0.3, and check the answer. Easy math. Now it's time to learn about something really cool, and that is cubed roots. Now I'm going to go ahead and highlight the word here because it is a definition, and we're going to find the definition down here in the words thing, and it says a cubed root of a number is one of its 3 equal factors. You notice that word 3 right there? That word 3 is important. It's what number times itself 3 times equal the number that's given. Given with symbols, that means that if x cubed is equal to y, then x is equal to the cubed root of y. Notice how they have that little 3 up there in the crook of your radical sign? And then applying that to actual numbers, 2 cubed is equal to 8. So 2 would be the cubed root of 8. because there's 3 2's. 2 times 2 is 4, times 2 is 8. One of those 2's is going to become the cubed root of 8. Same thing here, since negative 6 cubed is going to be negative 216, then negative 6 is the cubed root of negative 216. Did you catch what they just did there? They told you that you could have a negative cubed root. You couldn't have a negative square root, but you can have a negative cubed root. If your root is an odd number, it can be negative. If your root is an even number, it can't. Now with square roots and all other even roots, you're always going to have a possible positive, possible negative answer. That does not apply to the cubed roots and any odd root. So for example here, the cubed root of 27 is always just going to be a positive 3, because positive 3 times positive 3 is going to be positive 9. Positive 9 times positive 3 is going to be positive 27. But if you put negatives in there, negative 3 times negative 3 is positive 9. Positive 9 times negative 3, that's going to give you a negative 27. So you're only going to get a positive root when you're dealing with cubes, or if any number root that's in that crook there is an odd number, it's going to be a positive answer. The cubed root of 125, that's going to be 5, because 5 times 5 is 25, times 5 is 125. 5 times itself 3 times. Now the cubed root of 0, that's going to be 0, because 0 times 0 is 0, times 0 is 0. So the cubed root of 0 is going to be 0, the square root of 0, well guess what, that's going to be 0 as well. The cubed root of a negative number, that's going to become a negative number, and we already discussed this earlier where I did the cubed root of negative 3, and I showed you how negative 3 times negative 3 was positive 9. Positive 9 times negative 3 became the negative 27. The same exact thing is going to be happening with the negative 5s. If you have a cubed negative number, it's always going to end up negative here, and if you have a cubed root of a negative number, it's always going to end up negative here. Now we learned earlier that a perfect square was going to be the square of a whole number. A perfect cube, well, that's going to be the same thing, only now it is going to be the cube of an integer, which means could be a positive or could be a negative. And I think actually perfect square, they use the term integer too, because that would work. The table shows some examples of perfect cubes. 1 cubed is 1, negative 1 cubed is negative 1. 2 cubed is 8, negative 2 cubed is negative 8, 3 cubed is 27, negative 3 cubed is negative 27, and so on. Alright, let's look at how to simplify the cubed root of 125. What we're looking for is what number times itself 3 times is equal to 125, and they go ahead and show you here that the answer is going to be 5, and that's because 5 cubed is 5 times 5 times 5, also known as 125. So what's going to go right there? The cube root of 125 is going to be 5. I've never understood why they give you a place to put the answer in for the happy sound when they already give you the answer. It kind of defeats the purpose of being happy. Once again, it's going to be your turn. This one's going to be pretty tough. Let's see if you can do it without a calculator. Figure out what number times itself 3 times is going to equal to 729. I'll make you a deal. You do it without a calculator, and I will do it without a calculator as well.
It's almost the same.
Okay, it's my turn to do it. Now first off, I'm going to tell you my process through this. I need to have a number that is going to be multiplied times itself 3 times to be that. The first thought that comes to my mind is, well, what would 10 be? But if I use 10 cubed, that would be 10 times 10 times 10, and that would be 1,000. So that would have me too high. Besides, it's all even numbers, so my answer would be even, and I have an odd number there, which tells me that whatever number I'm multiplying times itself, that's going to be an odd number too. Now in class today, when we were doing lesson 3, which is what we actually did, or excuse me, chapter 3, while I'm recording module 5 here, we did 7 cubed and found that 7 cubed was going to be 343. So I know it's got to be a number bigger than 7. I know it's got to be a number less than 10, and I know it has to be odd. So I'm going for 9. 9 times 9 times 9. Of course, 9 times 9, that's going to be 81. And 81 times 9, well, 1 times 9 is 9. 8 times 9 is 72. And there it is. So my answer, the cubed root of 729, is going to be 9. Circle my answer. Jump back over here. Type in my answer and check it. Happy sounds. This looks like a good place for us to stop this video in part 2. When we come back for part 3, we're going to work on some cubed roots of negative numbers, which I bet you could already figure out how you're going to do them.